Now we are discussing, there is another method called early stopping. We generally use for overfitting, to avoid overfitting. What is this early stopping? On the x-axis, we are taking the number of iterations and we are trying to check with each iteration how the cost function is changing, the error, the training set error and the development set error. Now you can observe with the increment of the iteration, as every iteration is proceeding, the training set error is decrementing. But the problem is when the iterations are going on, in the development set error is decrementing only up to a particular point. After that, it is incrementing. So we have spotted it. Because the development set error is incrementing after a certain point, we are saying restrict the number of iterations up to this point. So we are stopping this process very early. That's why we are calling it as a early stopping. By using the early stopping, we are giving a solution. If you take this many number of iterations, then you will get the solution for overfitting. Then your data will not overfit. Actually, this solution we are showing for the overfitting has one disadvantage. What is that? Generally, we deal the problem of optimizing J value, means minimizing the J value, and the problem of overfitting independently. We do not see these two problems at a time. For the optimization, we use the gradient descent. For the overfitting problem, we go for the regularization. But here, you are trying to address the overfitting problem and the optimization of the J at a single point. Because of this, if you are saying, if you minimize, if you do not want your data to overfit, then take the minimum value of J only, this value only. If we have iterated more number of, if we could have iterated more, then we will get minimum value of J for the training set. And if we used the L2 regularization, we might have got even the training, the cross-validation data set error also small. But only thing is, when we use the L2 regularization, we have to find the lambda, a hyperparameter. The choosing the value of lambda itself takes many number of iterations. So every time we have to check by taking first lambda is equal to 0.1 or lambda is equal to 1 or is lambda is equal to 10. We have to check for different values. After checking for different values, randomly some value may give the best output. Then we can fix that. This will take a very huge amount of time. So compared to the L2 regularization, early stopping gives the solution very easily in very quick time. But we cannot say this is a very effective solution. Why this is an effective solution? Because this is not addressing the two problems which are orthogonal to each other. This is not addressing the two problems in the two different ways, but it is addressing the two problems in such a way that we are making one to depend on another. We are saying if your learning algorithm that you are designing the neural network, if it is if you want it to not to overfit, then take the minimum value of J in such a way that you should stop the number of iterations at this particular point, and you should satisfy with this J minimum. That is the disadvantage with the early stopping.